Morning, good afternoon, or good evening to you wherever you're tuning in from today. And we're absolutely thrilled to welcome you to Nomad 1.0 launch day. We can't wait to show you all the things that we've been working on. And it's been a long time coming, and we can't wait. My name's Jackie Grinrod, and I'm the developer advocate at HashiCorp that's focused on Nomad. And I'm also going to be your host for today's session. So just before we get started, let's take a moment to review the agenda, and we'll cover a little bit of housekeeping on the platform. So first up, we're going to have Armon coming on to talk about the introduction of Nomad 1.0. You may or may not know him as our co-founder, or maybe the guy that does really awesome whiteboards explaining technical concepts. Our second one, we're going to have a live demo, or not a live demo, a recorded demo of dynamic application sizing by one of our engineers. We'll have another demo after that for the topology visualization demo by Michael. And then we'll be doing a Q&A session after all of the other sessions with myself, Armon, Nomad engineers Chris and Michael, and Nomad engineering management, Gail and Ishan. And so just to point out that on your left, you'll be able to find the Q&A beside each session. And there'll also be our slides and different media browsers to be able to watch what we're doing during the webinar. And with that, I think we're good to hand over. Armon, would you like to come on and talk about Nomads 1.0?
Thanks so much, Jackie. Awesome. Well, very excited today to be talking about Nomad 1.0. As many of you might know, it's been a long journey to get here. So I'm going to spend a little bit of time talking about sort of the journey of what it took to actually get here, to get to the Nomad 1.0, as well as a bit of an overview of what's in the release. And then we got a bunch of cool demos lined up showcasing some of this functionality. So with that, I want to kind of jump right in. I think when we talk about Nomad's journey, it's hard to believe at this point that it's been out for about 5 years. And I think we started with a relatively straightforward goal. What we wanted to do was create a single method of doing orchestration across any type of cloud, across any type of operating system, across any type of packaging format. And so it's sort of hard to believe for us as, when we started thinking about Nomad, circa 2012, circa 2013, there really wasn't containers. Docker didn't exist at the time. There wasn't sort of well thought out orchestration solutions. Really thinking about more abstractly the problem of how do we move developers up from thinking about underlying infrastructure and host management into really application lifecycle and focusing on what they care about, which is app deploys, scale up, scale down, version changes, things like that, and decoupling them from the infrastructure, regardless of what that infrastructure looks like, regardless of where that infrastructure might live. That was sort of the original vision and continues to be the guiding vision for Nomad. So it's been fun to see just how far we've come from that vision. I think along the way, there's been kind of two primary guiding principles for Nomad, right? One has been simplicity. And so this is, particularly when we think about container orchestration, how do we make it simple? How do we abstract as much of it as possible? And I think you see that sort of all over the place, right? I think part of that is the sort of ethos of the Nomad job file, right? So a single declarative job file that captures everything about the workload, right? That's meant to be very human readable, very concise, not a whole lot of boilerplate in there, right? Really looking at, great, if I'm the user and I'm specifying these jobs and I'm working with Nomad every day, how do I make that simple and enjoyable, right? From all the way to the design of command lines, to the design of APIs, to the design of the UI, strong focus on simplicity of the system, right? Same on the operation side, how do we make the system robust, easy to operate, predictable, much like we do with the rest of the HashiCorp tools. At the same time, we don't want that simplicity to sacrifice any flexibility of the system, right? So even today, Nomad works across multiple different operating systems. It supports multiple different types of driver formats, right? So you can run everything from VM images to containers to Firecracker, sort of serverless type applications. And so we don't sacrifice any of that flexibility when it comes to non-containerized workloads or even alternative container formats. Right? So these have really been the guiding principles as we've continued to evolve Nomad over the years. So taking kind of a quick look, like I said, Nomad was first released about 5 years ago now at our first ever HashiConf in 2015. It's gone through a tremendous evolution since then. Just, some of the kind of highlights were, the following years when it first had Vault integration. Now, of course, we have fairly deep integrations with Vault and Console as well. It wasn't until 2 years after the original release that we added Nomad Enterprise. So really looking at some of our largest customers and the challenges they face at scale. And then including more sophisticated integration with Console to include server-side restarts, more sophisticated health checking, things like that. And then last year, really focusing on expanding the scheduler capability, moving from just a bin packing approach to spread approach, more sophisticated affinities instead of hard constraints, preemption of workload, a new architecture for client plugins for tasks and devices, et cetera. And I think what's been fun is just the acceleration of change that's happening, right? And so part of this has been driven by a larger community. Part of this is driven by a larger Nomad development team, more customers with different, varied asks. And so when we just look at the releases highlights for Nomad 012, which was the last major release, it's huge, just the number of major features, right? Things like container networking interfaces, CNI, so that we can, plug into your favorite type of network overlay underlay solution. More sophisticated Windows support with things like the Windows IIS driver, right? Multi-cluster deployments as we're spanning multiple data centers, multiple cloud regions. More sophisticated scheduling with things like spread rather than bin packing, right? So there's a ton of features that, I'm not going to spend time on all of them, but what you get a sense of is just the sheer volume. And these are relatively large features, right? When you talk about core changes to the way the scheduler works or new drivers, right? Or integration with things like CNI. If we look just before that at some of the major highlights of 010 and 011, also you can continue to see that trend. Things like container storage interface and really looking at how do we better handle stateful volumes, right? Was a fairly large upgrade both architecturally and in job specification and just the system's design. But then putting in primitives like scaling APIs so we can decouple the job specification from scaling, which has enabled us to create a set of auto-scaling kind of controllers that live outside of Nomad and can automatically do vertical and horizontal cluster scaling, right? So really setting foundation for things like that. Major upgrades in the UI, improvements to networking, really these very large foundational upgrades. And so, when we talk about all these features, we want to give a huge thanks to our community contributors. A lot of this is driven by your feedback, your contributions, your testing and providing us that sort of invaluable feedback that helps to make the product much better. So thank you to all of our community superstars for all of your help. And I think another, if you had a chance to attend HashiConf a few weeks ago, we had a great series of talks by some of the world's largest organizations that build upon Nomad and trust Nomad, sharing their use cases, how they use. And so here's just a handful of the companies that you may recognize that build upon Nomad and use it as a foundational part of their infrastructure, right? So it's very cool for us to see how varied this list is, from very large traditional businesses that are globally systemic financial institutions like BNY Mellon, to much smaller startups that are making a bet that this is a simpler solution for them and reduces their operational sort of overhead, right, as they're working to scale and build their product. So a huge range of companies using Nomad. It kind of speaks to sort of the user base and how it helps you go from very small to absolutely enormous and sort of doesn't sweat along the way. Some of the stats we like to share that some of our customers shared recently. So Roblox, if you're not familiar with them, large video game company, huge growth given COVID and over the last few years in general. And they shared how they're running Nomad across 11,000 nodes in 20 different clusters, right? Q2 shared that they're running over 37,000 tasks on their Nomad cluster. Cloudflare shared how they power their entire edge CDN using Console and Nomad. So they span over 200 different points of presence. And for several years ago, at this point, 2016 maybe, we did what we called the Million Container Challenge, where we looked at how quickly could Nomad deploy, and could Nomad deploy 1 million different containers at a time. And so at the time, we partnered with Google to do this Million Container Challenge, and the result of which we showed, across 5,000 nodes, Nomad was able to bring up 1 million plus containers in under 5 minutes, in about 4.5 minutes to be precise. So it's been many, many years of Nomad development since we've made the system much more robust, much faster, improved things like the scheduler. And so now we're partnering with Amazon on doing an even larger benchmark that we call sort of the million-plus container challenge. And so we're super excited to share the results of that in the coming weeks as we really look at taking Nomad up a degree to an even higher order of magnitude in terms of the workload we can place on it, and hopefully share those results on Nomad 1.0 as well. So with that, I want to spend some time talking about the reason we're all here, Nomad 1.0. This is a very exciting milestone. For those of you who follow HashiCorp, what you'll know is we don't take the 1.0 milestone lightly. It took Nomad 5 years to get here, but honestly, it takes most of our products, at least 5 years to get to the 1.0. It's a bar that we hold very, very high. And what we really expect of a 1.0 is, that we very well understand the use cases, that we've flushed out and achieved maturity in 95% of those, right? That the core architecture is stable, battle tested, running in production for thousands and thousands of hours, and that we've caught the vast majority of the bugs you're going to experience. And so it's a very high bar we hold in terms of just the quality, the robustness of the design, and sort of the completeness of its feature set. So it's exciting for us to feel like we finally achieved that and to be able to share that with the community. So what are we talking about solving with Nomad 1.0, right? And it comes back to sort of our same guiding principles, right? It starts with simplicity, right? And looking at things like, how do we right-size our applications, right? How do we optimize resource spend and make sure that we're not over-allocating or under-allocating resources? How do we make visualization and understanding the system much simpler, right? And when we talk about flexibility, how do we make the system work better at any scale, right? So as we get even larger, multiple regions, global scenarios, how do we make sure that's simple, right? How do we make the open source more capable, right? And how do we support more flexibility in the job format? So we're going to talk about some of this, but as just a quick highlight of some of the features we're going to be talking about, right? We will be talking about namespaces within Nomad and how that's moving to open source. We'll talk about visualization on the cluster, dynamic resizing of resources for tasks, HCL2 support and the flexibility that brings, event streaming and real-time notification of things happening on the cluster, as well as some other more minor enhancements. So first up is talking about namespaces, right? Historically, these have been a feature that only lived within the Nomad Enterprise product. So if you were a customer of Nomad Enterprise, you could have multiple namespaces, and this was used for enabling a multi-tenant cluster. We're now bringing that to open source, so you can use it no matter what, whether you're a small shop using it to divide your dev test environment, or you're a very large shop using it to enable more multi-tenant setups or ephemeral namespacing. And so that'll be integrated and works just the way you'd expect. All of the APIs are namespace aware. You can do a Nomad namespace list. The UI has namespace awareness. And it gives you what looks like a mini version of your own Nomad cluster, when in reality, you're still multi-tenanted on an existing single physical cluster. Next up is event streaming. So this has long been asked, right? So with Nomad, traditionally its API supports what we call blocking queries, meaning you can make any API request and block on that API endpoint until the results change, right? So for example, you could ask for the list of jobs that are registered, and then you might block on that up until the list of jobs changes, right? Now, what's nice about that API is it gives you an ability to get sort of a real-time feedback when something changes. The downside of that is it puts a burden on clients to figure out what exactly changed, right? Nomad will deliver to you an updated set of all the jobs, but you're going to have to do the delta between them to say, okay, great, between results at A and B, what's new, what got removed, what was modified, right? Versus with an event streaming API, what you'll get is basically a full stream of just those deltas, right? So in this case, you can see an example of we're just curling the stream endpoint, and what we can see is that a node registration took place. So a new node was just registered in the catalog. So this makes it much, much easier to build tooling around and on top of Nomad that's reacting to things as they happen, right? So particularly if you think about like autoscalers or integration with monitoring systems where you might want to tie into node registration or deregistration or job registration or deregistration to be able to hook into other monitoring and alerting systems, or to enable your own type of auto-scaling behavior. This API gives you a much richer primitive that's a little less cumbersome to work with, as you're working with that kind of real-time stream of what's happening right now. Next up is HCL2 support. So if you're familiar at all with Terraform, you'll know Terraform went through sort of an upgrade from HCL1 to HCL2, HCL being the HashiCorp configuration language. And so by and large, they're very similar. You'll notice the syntax is not a radical change from HCL1 to HCL2. The difference is it cleans up a lot of things and adds a lot more flexibility in terms of interpolation, in terms of variables, in terms of making configuration much more dynamic, right? And so here you can see things like different function calls taking place, right? So there's a function call under the environment variable where we're lowercasing a variable. You can see in the template stanza we're making file calls. And in general, it cleans up some of the edges of HCL1, right? Makes it a little bit more consistent, a little bit more human readable, but at the same time adds more flexibility and more power, right? So that you get a simple, again, format that's easy to understand, but flexible enough to fit into the most sophisticated use cases, right? Next up is topology visualization, right? So that's very, very excited about this. This has been a long requested feature, is the ability that once you're running at scale, can you quickly eyeball to understand what's my density, what's my utilization, is my cluster properly configured, right? Am I under capacity, over capacity, et cetera? And so humans are deeply visual, and it's much, much easier for us to grok that in a visual way than to try and pour over reams of tables and try and piece together what the situation looks like. And so now there's a much richer topology visualization that'll give you multiple levels of detail, right? You can see at a cluster-wide what density looks like. You can see at a node-wide. You can click on a particular job or allocation and view the related ones. And so you can kind of see how is a job being placed across a cluster, right? So it gives you a much more visual way to interact with the cluster and get a sense for how is it behaving. Next up is the kind of constant feedback we get that sizing applications is hard, right? If you undersize, you risk, performance issues, you risk, the application crashing because it runs out of memory. If you oversize, you lead to waste, right? You have idle resources that can't be utilized because they're being reserved for a job who's not actually using it, right? And so some of the things we hear about is, people complaining that it's difficult for their developers, that they spend a lot of time on allocation, that people end up being conservative, so they over-allocate, and this ends up with resource waste. So we've heard from many different people that this is an ongoing challenge. And so we're excited to introduce a new capability that we call dynamic application sizing, right? And here's an example of it within this sort of UI. And so you can see here, based on the profiling and observing the telemetry off this task, what Nomad is recommending is we increase the current allocation from 100 megahertz of CPU for this Redis task to 700 megahertz, right? And you can see some visual illustrations of things like the P99 of utilization. And here we basically have a sort of suggestion dialog, right? So Nomad will not auto-apply the change, but it will provide you a suggestion, which you can choose to accept or you can choose to dismiss, right? From within the configuration itself, you enable whether or not Nomad should do this type of profiling, right? So here we can see two different policies being enabled. One is a CPU policy, one is a memory policy. And you can see how you have different knobs in terms of configuring how the system should work, right? So with CPU, for example, we might target the 98th percentile of utilization, right? Versus with memory, we might say, 98th percentile means we're still crashing the app, so just go with the absolute max, right? That sort of 100th percentile that we've seen, right? So you can implement different policies, and these are going to be, flexible so that we can expand and add new policies over time to continue to make the system more sophisticated. So it's just a kind of a quick recap of Nomad 1.0, right? The namespaces from enterprise are moving to open source. We're adding point-in-time topology visualization to make it much more obvious how the cluster is behaving. We're adding HCL2 support to make the job file both more simple but also more flexible and powerful. We're adding event streaming, right? So it makes it easier to build on top of and consume a real-time view of what's happening with the cluster. We're adding dynamic application sizing to the enterprise version to make it easier to right-size your resource utilization, as well as many smaller kind of bug fixes and enhancements that are coming along with it. If you want to read more about it, we have our Nomad 1.0 blog post that goes into a bunch more detail. If you go to the HashiCorp resources page, there's a lot more content about Nomad if you're new to it and want to dive a little deeper. And if you want to try Nomad 1.0 for yourself, The open source versions are available for download, and the enterprise versions are available for trial as well, right? So you can go to either website and kick the tires right away. And with that, I want to hand it to Jackie, who's going to do a series of demos for us on some of this new functionality. Take it away, Jackie.
Thank you so much, Armon. So the first demo coming up is by Louise, and it's going to be on dynamic application scaling. He couldn't make it today because he's hard at work on the release and trying to make sure that everything goes smoothly, but he still wanted to share this information with you. After the rest of our demo sessions, we'll be doing Q&A, just a reminder, and Chris, our ecosystem team lead, will be here to answer questions on dynamic app scaling. And with that, let's just get to screen sharing. You should be able to see it in just a moment. Perfect.
Hi, my name is Luis Aoki. I'm an engineer in the Nomad team. And today I'm going to talk about a new feature coming in the Nomad 1.0 called dynamic application sizing. So let's jump right into the demo. Here I have a cluster running a few jobs. And you might recognize the example job here, which comes with the Nomad CLI. This just runs a Docker container with Redis. And the point of the demo today are the resource limits for CPU and memory. As you can see here, the job was started with 500 megahertz of CPU and 256 megabytes of memory. Now the problem is, if we look at the allocation, the actual usage for that, for CPU and memory, is actually much, much lower than what we had specified in our job spec. Now this is a common problem because when you're creating the job spec, you don't actually know which limits to put there until your application is actually running and running for quite some time. So you want to monitor your application and then look at the actual usage and then keeping your job spec updated, which is a very hard and time-consuming process. Now, what dynamic application size gives you is we have this new item here on the Nomad UI called Optimize, where you can see that the Nomad autoscaler is going to monitor the tasks for you and make recommendations. In this case here, it's recommending us to reduce our CPU and memory limits for this Redis task by quite a bit because it was way off the mark when we initially submitted. You can see also here that I can control what kind of recommendation I want to accept. So I can accept only the memory change or the CPU change or both. And it also provides you with some quick stats around the actual usage level to kind of give more context around the recommendation, just to help you to make a decision on whether to accept or reject this recommendation. So I'm going to go ahead and accept this. And what's going to happen is the Nomad is going to redeploy my job with the new recommended resource limits. So looking again at the example, we can see there's a deployment going on and that the new reserved CPU and memory limits are way lower than before. Now, looking at the allocation usage, you can also see that this reflects the usage much, much better. And now there's no wasted resource. So Nomad can use all of those allocated but unused resources to other workloads. So this helps with not having resource waste, and then you make better use of your infrastructure. These recommendations are actually happening constantly. So behind the scenes, the Nomad autoscaler is monitoring your tasks. So what I'm going to do now is I'm going to dispatch a job that is going to generate some load into the cluster. So it's going to run the Redis benchmark CLI to generate traffic into Redis. And you can see here that right away that the CPU usage spiked quite a bit. Now, let's say that this is not a good example for dynamic application sizing, just because normally you don't have this sudden spikes of traffic, but it's going to be good enough for a demo here. Now, if I look again at the Optimize tab, I should see the autoscaler making a new recommendation here for the Redis task. And you can see now that since now we have traffic coming and we actually have load in our server, see that the new recommended value is quite, it's bigger than we currently have. And then looking at the statistics, we can see that it's actually going above the maximum value we've seen. So the UI shows you some context around why it's making that recommendation. And you can see that the recommendation is actually above the maximum just to be safe. So it's going to recommend a little bit more than what you actually need, just to kind of avoid starving your resources. So I'm going to go ahead and accept this recommendation. And once again, Nomad is going to redeploy my job with the new resource limits in place. And we should see, what we should see now is that with the new resource limits, if you look at the allocation usage, we can now see that they match our actual usage much closer now. So there's less resource being wasted because they're allocated and not being used. And there's also no resource starvation because we have quite a bit of a gap there so the workload can grow. And this will happen constantly because the autoscaler is constantly monitoring that for you. So that was the demo of application sizing. And now let's look at the details behind the scene of how all of this works. So as I mentioned before, I had running the autoscaler as well. And the autoscaler is the component that is going to constantly monitor your APM for metrics. It's going to look at Nomad for policies, and then it's going to make scaling actions to your target. So what's new about dynamic application sizing is that the target now is a new API endpoint called Recommendations API that we added into Nomad 1.0 that is going to make those recommendations cards that I showed you on the UI. So that's the new target for dynamic application sizing. And then the new policies that we have coming, they're going to be placed in the job spec. If we look at the example job that I showed earlier, you can see that we now have these new scaling blocks here that when you add this into your job spec, Nomad will automatically create new vertical scaling policies on job submission for you. And the autoscaler is going to read them and make those recommendations. And lastly, the final components are the new vertical strategies. The autoscaler so far will look at your APM for a few minutes of data, but with CPU and memory recommendations, we're going to look at a broader, more longer period of time, usually around like days worth of metric. So this is what the new vertical strategies allow us to do. So as we've seen, the recommendations APIs are advisory first, which means there's always a human in the loop to analyze, accept, or reject those recommendations. The autoscaler is constantly monitoring your tasks for usage. So even if you have a new deployment that uses more memory for some reason, or you have an increase in traffic, the autoscaler is going to pick up those changes automatically and make these recommendations for you. And then when you accept the recommendation, we're going to use the existing beta-tested Nomad deployments to do the updates. So you can have, you're going to follow your job update semantics. So you can have some things like canary deployments, blue-green deployments, or even automatic rollbacks when you're accepting or rejecting these recommendations. The new recommendations API, the new endpoint that the autoscaler is going to use, and it's going to submit which resource it wants to change and what's the new value, as well as additional statistics, just to give more context for operators to make a decision. And then the other endpoint is to accept the recommendations, and you accept we can accept them in bulk, so passing multiple recommendations to apply or dismiss. So if you want to have automatic accepts, you can do so using the API. And the new strategies here for dynamic application sizing, as I mentioned, we want to look at days worth of data. So when you're actually running this in production, you're not going to get recommendations right away, just like happened in the demo. Like I kind of tweak things to make things go faster. But the autoscaler is actually going to wait for a few hours or even days worth of metric before it can be more confident that it understands your workload patterns. So it's going to collect and analyze days worth of metrics to make a recommendation. And this is kind of different how it was done before. And all of these recommendations, they are targeted to help you minimize cost. So it's going to reduce the resource waste, while at the same time not compromising availability. So we want to reduce the the amount of allocated resources without going so far as compromising availability, so that your tasks become starved out of resources. So they run out of memory or they become CPU throttle. We don't want that. So whenever we make a recommendation, we actually add a safety margin to the recommendation just to be extra careful. And then if your workload kind of starts to see less load, we're going to slowly decrease the recommendations, just so in case you get another spike, we're kind of ready for that. So, you know, these strategies are always kind of trying to find this balance between minimizing costs without compromising availability. We have three new strategies coming with dynamic application sizing that you can use in your job specs. The first one is the maximum strategy. So when we're collecting metric, we are using a rolling window to analyze the time-based metrics and turn them into usage histograms. And what the maximum strategy does is it looks at the past n windows. By default, that's about 1 week worth of data. And it's going to report the maximum value used. The maximum value has seen over this period. This is a good strategy for things like memory levels for jobs that are not very tolerant to out-of-memory errors, because it will always give you the maximum value that you actually used plus best safety margin. The average strategy is kind of similar in a way that it's going to look at about 1 week worth of data and give you the average instead of the maximum value. It will also apply a time weight decay function so that newer metric values are more important than older ones, just so it reacts faster. So normally average is kind of slow to react to changes, but applying this time-weighted function, we can more quickly react to recent changes. Now, this is not a very flexible strategy, and it's going to be used in very specific use cases, such as CPU levels for bad jobs that have sort of like a constant usage of CPU when they're running. Unless the most flexible strategy is the percentile, because it allows you to actually define which percentile level you want to use. Now, when you're computing the percentile, it's a bit different than what you get from normal APMs or test Prometheus. And the difference here is because since we are using this window-based approach where we are aggregating the time series into windows, we're actually looking at not only how old the samples are, but also how often they occur, so that our recommendation more closely resembles the actual usage. And this being the more versatile strategy, is very good for like CPU values for jobs, and then memory allocation for jobs that are more tolerant to out-of-memory errors that could survive like a restart, like occasional restart. So this is sort of like trade-off between having more resources available at the cost of potentially having some out-of-memory error. So the percentile strategy allows you to kind of play around with the param for the which percentile you want. So you can start with something like a 99th percentile, see what kind of recommendations you get, and then kind of change that depending on what you're seeing. So that's why it's the most flexible option out there. And then, as I mentioned before, to start using it, it's very simple. You just add these scaling blocks into your job specs, specifying which resource you are monitoring. So on the left, we have a CPU scaling policy, and then right, you have a memory scaling policy, and then which strategy you want to use. And then for burst size specifically, what kind of burst you want. So that's the strategy configuration. So that's the param that you can change to fine-tune the recommendations. And that's all I have for today, and hope you enjoyed. Thank you.
Awesome. Thank you so much, Luis, even though you're not here today, but it's really appreciated. And so just a reminder that we'll be doing Q&A at the end of today's session. So we have one more demo coming up, and then we'll be doing the Q&A. So up next, we're going to have Michael, who will be speaking about topology visual. Why is this so hard to say? He'll be speaking about the topology visualization demo. All right, Michael.
Thanks, Jackie. All right, so just to set the stage a little bit, I want to go back to these guiding principles that Armon laid out of simplicity and flexibility, because they both apply to the topology visualization as well. First, though, let's focus on just simplicity. This is something that you've heard about Nomad a lot. In fact, you've probably heard the phrase, Nomad's just a single binary, so it's easy to run. And while that's technically true, what ends up happening in a production environment is you have a whole collection of services running that are just serving Nomad, console and Vault, just to name a couple. And I think this is most apparent when it comes to monitoring. You end up with multiple tools, since Nomad itself doesn't have a first-party monitoring tool, but does expose telemetry data. So knowing this, you probably set off to Google like any good engineer, and you end up on this lovely guide written by our amazing education team about using Prometheus to monitor Nomad metrics. Now, if you're like me, first thing you do when you open up something like this is look at the scroll bar just to see what you're in for. And when it's this size, you kind of wonder, how'd you end up in this place? But nevertheless, you continue and you do get these tools connected. And along the way, now you have Prometheus running, you probably have Fabio or Traffic running if that wasn't already in there. But it's working now. Data is being synchronized, except that's kind of only half the story. You're also going to want to create some dashboards. So to make those dashboards, you need to know what metrics are actually being emitted through a telemetry process. So you do some more Googling, and then you end up on the reference material for metrics. And again, you're kind of wondering again, what series of steps led you to be on this page with this small of a scroll bar? So maybe you don't read everything on day one, and you instead just sort of Google about to see if there's anything that can serve as a starting point. So there's some community contributed Grafana dashboards that are kind of out of date at this point, but surely it's a starting point. It offers some code. You can start there and just sort of mix and match until you end up with something you're happy with. And I've been calling this the OWL problem. So with monitoring, we say it's simple, but then you end up having to actually go through quite a long series of steps to get to something that represents this OWL. This is sort of like the classic situation where what you thought was a one-day task ended up being a 2-week task, and you're still kind of not entirely sure if you're done yet. So I'm not going to say that topology visualization completely fixes the monitoring story, but I do think that we're trying to address this OWL problem in a little bit. So I'm going to start this demo now. All right, so to view the topology visualization, first thing I want to do is open up the UI in a 1.0 cluster. And then you'll see this topology link, you click it, and then you're done. So no configuration, because everything is sort of this opinionated view built on top of Nomad's APIs. A much simpler story than having to set up all the telemetry and third-party tools to get any idea of introspection into a cluster. This is going to be the first of 3 clusters we'll look at. This is a small one, only 10 nodes here, 25 allocations. At this scale, you look at this and you go, yeah, that's about right. You probably know all of the jobs that are running in your cluster at this scale. So this is sort of a reflection of the mental model that's in your head. You can think, yeah, there are nodes. These are probably like the bigger allocations. I can think of what jobs these must be. We end up with sort of a spread. Maybe we could actually consolidate a little bit and save a node. But this isn't surprising because at this scale, you have an idea of what everything is. But let's look at a larger cluster. So this one represents a hybrid infrastructure. We can see this data center of Metal HQ. So this is your on-prem data center, but you're sort of starting to port things into the cloud. So here, this is when you're stubbornly trying to know everything that's going on in your cluster. You really want to keep tabs on all the allocations, but there are more developers than there are ops people. You can't keep up, so every once in a while you get surprises. And while you're moving into the cloud, it's very important that jobs are deployed in a manner that is going to meet criteria for the different environments. So for instance, if we were to look at this, we can see that this allocation is well distributed across this cloud data center, but it also has a couple straggling allocations inside of our bare metal on-prem data center. And this is going to have networking implementation. So if this job isn't configured to account for that, then it's possible that we're actually dropping something like 20% of our traffic on the floor. And it's nice to be able to catch this ahead of time in this manner, rather than finding out when it becomes a page at 2 a.m. Or we can look at this one over here and see that 3 instances of the same allocation ended up on the same node. And this is going to have availability consequences also. It's possible there's a missing constraint in this job. So now we've sort of discovered that in this exploratory view, rather than a DM from our boss or from our SRE team. And in this last cluster, we're going to look at something larger. So many successful businesses will never get to this scale. This is a lot of compute, but these clusters are out there. In fact, we have much bigger clusters. Nomad can scale much bigger than even some of the largest clusters we've seen, as evident with the million container challenge. So here we've dropped the node labels. Everything is sort of textural at this point. We can see there's sort of a broad distribution. We're probably using a spread scheduler in this case. Lots of allocations are starting because at this scale, there's always activity. And even though the Nomad, or even though the UI will keep up and it can draw lines between all of this, you may find that you've sort of outgrown this view. And that's totally okay. So going back to flexibility here, we expect there to become a point when you outgrow this native tool and you want to explore telemetry. In fact, I think the two can complement each other. I think that it's totally possible for you to have Grafana dashboards that are built specifically for your cluster, while also finding value in this topology visualization. Most importantly, I hope that having this topology visualization on day 1 helps prepare you for, say, day 50, day 100. So you know more about Nomad's data model when it comes time to actually create those dashboards that you're going to find helpful. Because we never want to move away from flexibility. Having this opinionated view is great for the day 1 experience, but we live in this software. We want to customize it, just like we want to rearrange furniture in our house. So we would never want to get away from that. In fact, the opposite is true. With the event stream, we're making it even easier than ever to add custom tooling on top of Nomad. So don't be afraid that that's ever going away. We just want to have this sort of on-ramping experience. So drawing the owl is more than just a 2-step process. And we're going to be changing this with time also. So expect the topology visualization to become even better for clusters large and small. Back to you, Jackie.
Awesome. Thank you so much, Michael. I always love your demos. I feel like I learn something new every time. I mean, I do that with most demos. But anyway, we're going to be going into our Q&A portion of the session now. So our moderators have been going through and taking your questions and adding them for us to, well, ask live. And if you have more, feel free to keep putting them into the box. Our first question is going to be for Armon, just to give you a moment. And it's a 2-part question. So the first part is, when will we see HCP Nomad? And the second part is, what is the grand vision going for Nomad going forward? Okay, we'll come back to Armand because he just needs a moment to switch his mic over. So we'll come back to that question. And instead, I guess the first question will be for Chris. And it's, is there a way to get dynamic application sizing to output to a .nomad file? I'd like to have a way to have it feed back into my infrastructure as code repositories.
Yeah, that's a great question. And that's something that we talked about while we were in the design stage. There's actually a number of different options here. The first, that during the beta period, we're going to be updating the job registration endpoint so that you can update Nomad jobs without overriding existing resource levels. Similar to how we did this with the Nomad API for horizontal autoscaling. You'll have the ability to send in an updated job spec, but tell it, go ahead and keep my resource levels where they are, because I know as an operator that I have dynamic application sizing running on the side here. The other approach is that the entire API is programmatically accessible, so you can look at recommendations, you can look at jobs, you can get these back out again. And if you have a human in the loop, of course, they approved that recommendation. If you have another system, then it knew what the change was as well. And then lastly is just to have other outputs from the autoscaler, so that instead of sending these recommendations into the recommendations API for looking at in the UI, you could just emit them to some other endpoint, some other sync like Prometheus or whatever is appropriate. So we'll be making that that is already pluggable, and we'll be continuing to build on that.
Okay, awesome. Thank you so much, Chris. And I think Armand's back. So we'll go back to the first question now. Let me just find it again. There it is. So two-part question. The first part was, when will we see HCP Nomad? And the second part is, what is the grand vision for Nomad going forward?
Sure, yeah, I think two good questions, and apologies for the technical difficulty. So with HCP Nomad, I think, hopefully what's sort of clear after HashiConf this year is, our vision for HashiCorp Cloud Platform, or HCP, is that it will have all the HashiCorp products as a service across all the clouds. So certainly HCP Nomad is planned as part of that. We don't yet have a committed date, but my broader goal is that hopefully over the next 12, 18 months, all of the products are available. So hopefully somewhere within that time frame. On the sort of second question, what's the sort of grand vision? In some sense, it goes back to the original mission, right? Which is, and I think with all of our tools, I think what we try and avoid is sort of a scope bloat over time, right? I think, if you look at the HashiCorp portfolio, we try and stay pretty true to the idea around have a well-defined mission and scope, stick to it, right? And kind of make sure it's composable with the rest of the ecosystem. So I think with Nomad, it really goes back to that original mission of how do we build a really great orchestrator that, again, cross-cloud, cross-data center, cross-operating system, cross-package format, does an exceptional job at that. And so I think there's a lot still that we can do to make it simpler, to make it, support more use cases within that vein. I think things like Firecracker are super interesting in terms of, how can we push the limits of how quickly a workload can come up and down, and what does that enable you to do if you have that sort of hyper rapid sort of 0 to 1 type capability. So I think there's not going to be a massive scope change of Nomad. I think it'll be continuing to go deeper in terms of the existing capabilities and a bit wider in terms of the flexibility of the system. And then as we move to sort of an HCP variant of it, it'll be services that we can build around Nomad to make it a richer experience.
Okay, awesome. Thank you so much. So our next question will be for Michael, and it's, what are your thoughts on hub and spoke visualization as a vertical/horizontal view?
Yeah, so I know exactly what they're talking about. So a sidebar for a second. The topology visualization had a beta period within the community. So if you want to do some spelunking, you can go to our community forums and sort of find the original post and see a screenshot of this visualization that they're talking about. And it's super neat, but one of the design goals for the topology visualization is density, and that's a very airy design. So using this sort of more block Tetris-y type approach, we can get a lot more density and show even more information on the screen at once.
Okay, cool. The next question we have is for Chris. And it's, can Nomad do auto-scaling, or does it always need a human to okay it?
Yeah, so excellent question. The recommendation, so I assume you're talking about dynamic application sizing. So we already have the Nomad autoscaler, which currently does auto scaling, true automatic scaling, horizontally for jobs and for clusters. The recommendations API can be automated. There are endpoints for listing and acting on these recommendations, and we emit the metrics about active recommendations so that you could build systems on top of that. But what we wanted to do is, building on 1.0, we're going to be adding new features to Nomad to make auto scaling more safe, right? So unlike some of these other ones, you know, it's as Armand mentioned in this talk, you know, giving too little resource utilization to a task can be very detrimental to it. This is why most people tend to run with tasks larger than they need to be. So as we go forward with after Nomad 1.0, we're going to be adding more features to Nomad Core that give us the ability to more confidently, more reliably, more safely do vertical auto scaling, at which point it may become the default workflow.
Okay, thank you. The next question we had is for Michael, and it's, does this cluster telemetry view make it possible to auto-scale a cluster without needing Prometheus or Datadog?
Short answer is no. So the reason we need something like Prometheus or Datadog is for that time series data that is used for the autoscaler to make projections. Since Nomad itself still doesn't have that time series data component, and I'm not sure if it ever will, to be frank, it's not really that the core scheduler's role is. We cannot use the topology visualization, which is strictly point in time, to make those calculations that the autoscaler needs.
Okay, awesome. The next question we had is for Chris. Do you have any idea whether job templating like Levant is on the Nomad roadmap?
Right, so HCL2 support in Nomad 1.0 can provide some of the capabilities that Levant did before. But if y'all didn't know about this, with James Frizzell, the author of Levant, joining the Nomad team earlier this year, we've officially adopted the Levant project, and we're going to continue to develop and support it in the Nomad team. So what this allows us to do is it allows us to continue to use Levant when it's the more appropriate tool, even as we continue to add more features to Nomad. So Levant's not going to go away. We're going to continue to add support there.
Wonderful, thank you. And the next question is also for Chris. Is Nomad Autoscaler available in open source?
Yes, so the Nomad Autoscaler has, it started as an open source. It's always been an open source project. It's available for horizontal job and horizontal cluster autoscaling. And as Louise noted during the demo, it uses an extensible plugin system to implement different parts of the controller, which folks can and actually have implemented plugins for. So some of our horizontal cluster autoscaling plugins and some of our APM plugins like the Datadog one came from the community. So the new plugins for dynamic application scaling were implemented in just this fashion. It's closed source, but the Nomad Autoscaler project is open source.
Thank you so much. So the next question we have is for Armand, and it's, can Nomad support edge deployments where devices are only occasionally connected?
Yeah, it's a good question. Today, architecturally, Nomad can't support that type of that sort of perpetual or sort of frequent disconnect. But certainly something we're looking at. I mean, I think we're seeing a lot more of these kind of edge deployment patterns. Certainly, I think Cloudflare is an interesting use case with hundreds of points of presence around the world. So an area for us to sort of explore, I think, in sort of a post 1.0 world, but architecturally today, Nomad sort of makes the assumption that clients are fairly regularly and with high reliability connected back to servers.
Perfect. Let's see, what is our next question? So our next question is for Chris, and it's, how does dynamic autoscaling, dynamic app scaling, there we go, handle scaling up resources? So how does it know how much additional memory is required?
So it doesn't know how much is going to be required. Unfortunately, it cannot see into the future. We're saving that capability for future products. However, what it can do, what most of these tools do, is it looks at the past application performance and it makes inferences about what the future needs are going to be, typically using statistical methods like some of the ones we showed in the talk today. So as you can imagine, we're excited about building on top of these approaches that we have and coming up with other capabilities, cross-job inference, other sorts of stuff, just as we're excited about putting checks and controls into Nomad to make this a little more reliable. But it is one of these, it assumes that future performance is based on the past metrics. So.
Awesome. So our next question is also for Chris. Is it possible or in our plans to have soft limits for memory allocation?
Yes, so oversubscription and soft resource limits is a planned feature on a roadmap. This is one of the ones that I had mentioned. True auto-scaling, vertical auto-scaling is done a lot better when you have that sort of thing in place. So an oversubscription system that allows us to have these soft memory limits, building on top of things that we already have support for, like preemption and priority, is something that we're looking forward to working on very soon.
Okay, awesome. I'm just checking to see if we have any more questions coming in right now to do. So we've got a couple more minutes left on the stream. All right, so another question that we had come in is, what is the ETA for general availability of 1.0? I'm not sure who's best to answer this one.
I'll answer it. The target, I'm being told, is December 8th. So the second week of December. We have the beta that's out right now, and we are going to continue to iterate on that. And yeah, but that's the target right now, December 8th for the GA of 1.0.
Okay. So I have a couple more questions that I'm not fully sure who they'll go to, so I'll ask them, and I guess if somebody could dibs to answer, that can be the flow for now. The next question that I had is, we run Docker on a Windows server. Are there any other Nomad customers doing this?
So I'll go ahead and take that one as well. There are a number of different Nomad customers that are doing that. A lot of, as you can imagine, a lot of people are using our Windows, and support for the exec driver has been very popular on the Windows platform. Recently, Roblox actually submitted a Windows IIS driver as well, but yeah, our understanding is that there are a number of different customers who are using Docker for Windows, especially as that platform has matured.
Okay, thank you. I'm just looking for more questions coming in. I mean, while I'm looking for more questions, I have a question for each of you, which is, what feature or part of 1.0 are you the most excited about? And I'll start with Chris, seeing as you just answered.
I'm excited about the event stream.
I was just going to, if it was okay, Chris, I was going to clarify a previous answer, which I think I'd said we don't support air-gapped edge installs, and I was mistaken, actually. So I've been corrected by folks on the Nomad team that in fact we do, and we have a great case study with Bowery Farms who talk about their use of this. So sorry, continue on, Chris. I just wanted to make that clarification.
Yeah, that's cool. Thanks. Yeah, no, I'm super excited. As you know, working on Nomad ecosystem, a large bit of the work that we do is outside of Nomad core, so we're interacting with Nomad through the API. So the ability to tap into the event stream and get you know, this sort of information asynchronously instead of relying on blocking queries like we have for a couple of years now is something we're very excited about. We're hoping to build a lot of fun tools on top of that, not only for our own uses, but to enable other third-party integrations.
Awesome. And Michael, what's your most excited feature in 1.0?
Yeah, I'm going to cheat a little bit and change the question, if that's all right. Just what makes me most excited about 1.0 in general. As an engineer, especially one who's worked on this project for 3 years now, I'm always looking at what's next, what's on the roadmap, and just sort of grooming the backlog and figuring out what the issues are that we can fix. But I think 1.0 as a milestone gives us an opportunity to sort of pause and look back and just see all the change and how much has happened in those 3 years I've been here, in the 5 years of the product in total. And that's just really rewarding to allow myself to do that. But yeah, plenty of awesome things. I'm also super stoked about the event stream and all the strides that the UI has made. I think that the dynamic application sizing UI in general, other UI engineer Buck did a great job on it, and it's going to be really awesome.
Thank you so much. And Arman, what are you most excited for in 1.0?
Good question. Probably the dynamic resource sizing, because I think for me it's sort of it's such a cool marriage of sort of simplicity, right? Again, how do we make something that is complicated feel really simple, but also the flexibility of the design of it, how it is configurable and pluggable, and you will be able to make it kind of fit a variety of different workloads, and I think that really speaks to the ethos. And I think one of those kind of features where we discussed it in 2013 when we imagined the product. So it's sort of cool to see 7 years later it actually become a reality.
That's really awesome. Like, actually. So I'm just going to answer the question myself too, because why not? For me, I'm most excited to play with Levant, to be honest. I've done a lot of Helm chart work in the past, and I'm really excited to kind of play with this and see where it goes with 1.0 coming out. All right, and I think we are at the end of our time. So with that, for any questions that came in, we're going to be putting those together into a PDF that will be getting emailed out to our attendees along with the recording. So if you didn't see your answer come up right now, don't worry. We'll be sending out the Q&As after. And I think that's about it now. So thank you so much, everyone, for joining. And we're really excited to see what happens with 1.0 and where this goes for Nomad. Thanks, everyone.